Hello everybody. Today I'll talk about the arithmetic sequence or arithmetic progression. Both of these terms mean the same, but well, they use both terms, so just don't get confused. They all mean the same. So okay, so to describe what an arithmetic sequence is, I think the best way to do that is just to give you an example. And one of the simplest examples would be 1, 2, 3, 4, 5, 6, and it goes on to infinity or to n, whatever. And as you can see, it's a sequence where to the previous term you add 1. So if we have 1, we add 1 to it, and we have 2. To 2, we add 1, and we have 3. To 3, we add 1, we have 4, and so on. We just add 1 to the previous term. And you might think, how do we get the first term? Well, it's just arbitrarily chosen, or if you have an example, you somehow derive it, but there's no real meaning behind it. In this example, I just chose 1. It could be 2, 3, 4, or whatever. Right, I'm gonna show you another example just so you sort of see how it works. Let's start with 4, just to show you that number 1 doesn't really mean anything. And let's have 7, 10, 13, and 16. As you can see, we add 3 here, then 3 here, 3 here, 3 here, the same pattern. We add 3 to the previous term. And so basically what that means, and well, that goes to infinity. Basically what that means is that the difference between 2 consecutive terms is constant. And in the IB, we call this constant the common difference, and we mark it as D. So that's common difference. I'm sorry, my spelling might be wrong, but that doesn't really matter. And that's basically the difference between 2 consecutive terms. And in the IB, we mark terms as U. So the first term would be U1, the second term would be U2, the third term would be U3, and so on. Right, so now that we know all these facts, let's try to find a formula that actually describes the nth term of a sequence, so the UN. So what is UN? Well, basically, to the first term we add 1, and then 1 again, and then 1 again, and then 1 again. So we basically add a certain number of 1s to the first term. So we have the first term, right? And how many times do we add the 1? Let's just use this as an example. Well, we do it to the 6th term, let's say. We do it 1, 2, 3, 4, 5 times. And well, we have this is the 6th term, so we basically added the number of term minus 1, so n minus 1, times the common difference, d, let's just say. And I mean, I just showed you on an example, but I think it's quite obvious that you added n minus 1 times the common difference. Right, so this is the formula from the nth term of the arithmetic sequence. So let's say we have a sequence, let me just 4, 8, 12, 16, 20. Okay, so U1 is 4, and common difference is basically the difference between 2 consecutive terms. So let's have U2 minus U1, and that's 8 minus 4, and that's 4. So the D is 4. right? Like, I mean, you know, you add 4, so I think that's quite obvious. So now that we know u1 and d, we can generate any kind of term we want. So let's say we want term 3, just so to see if our formula works. We have 4 plus 3 minus 1 times 4, so that's 12. Right, it works. And you know, let's say it goes to infinity, so let's have u 21. Okay, so we have 4 plus 21 minus 1 times 4, so that's 84. And well, you know, so and so on, so and somewhere here is 84 and so on. Alright, so we have the nth term. Now, they can ask you about the sum of the arithmetic sequence. So basically, what is the sum of all of these to the nth term? And we denote the sum as Sn. Right, so Sn is basically u1 plus u2 plus u3 plus u4 and so on until un. Okay, so we can, from that formula, we know that Sn equals un plus n minus plus d basically, plus un plus 2d plus u1 I'm sorry, plus 3d and so on u1 plus n minus 1 d. Okay, so now that we know that, we also know that Sn equals un plus n minus 1 d. I'm sorry, u1 plus n minus 1 d plus u1 plus n minus 2 d plus u1 plus n minus 3 d, and that goes to until u1. So we basically sort of flip the series. So this is the first and this is the last. I mean, it's exactly the same. And now, you know, it seems weird. I mean, it's obvious, but why would we do that? And it was actually Gauss who thought of that, and he was a really smart man. And at the age of 11, he actually thought of that if you flip the sum, right, and we add these two sums together, so we have 2Sn, well then we have u1, we have n minus 1d, so we have, so let's add these two together, so we have 2 u1 plus n minus 1d. So let's add now this part, so this is the second term, to this, and well that's obviously 2u1 plus n minus 1d, because we have here 1d, so we actually add 1d here, so obviously it's n minus 1d, plus, again, we add this part right here, and we have 2u1 plus n minus 1d, and so on, 2u1 plus n minus 1d. Okay, I sort of fit, because if we add this and this, we actually get this. I think that's kind of obvious. And well, we have n terms, right? Because, you know, u1, u2, u3 until un, so we have n terms. So it's actually 2Sn equals n times 2u1 plus n minus 1d, right? Because then there are n of those parts. N of those, so we have n of those, right? So Sn is basically n over 2, 2u1 plus n minus 1 d. And well, that's pretty simple, right? I mean, we had some infinite, well, not infinite, but we had a series that has n terms, and we come to a formula that actually, you know, uses the common difference, the number of terms, and the first term. Well, that's pretty nice, right? Yeah, I think it's pretty neat, and you know, it's a really hard proof to think of, and Gauss actually thought of it when he was 11. So yeah, he was an amazing man. And just to show how the formula works, let's just use our previous example, and let's have let's not pick a big number so that we can, you know, confirm it. S3. Okay, so we have 3 over 2 times 2 times the first term, which is 4, plus n minus 1, so that's 2 times common difference, 2 times 4. Okay, so that gives us 8 plus 8, 16. 3 times 16 over 2, which is 8 times 3, which is 24. Okay, so that's what the formula gave us. Now S3 equals U1 plus U2 plus U3, so that's 4 plus 8 plus 12. And well, that's 24. Wow, great. So, I mean, I know I just gave you one example, but I mean, you know, it's kind of obvious it works because I gave you the proof, but just sort of to show you that it works, I gave you an example. And basically all you can get on the exams is, you know, sort of manipulating all of the facts that you gather here. And I think that's about it. Thank you for watching. I mean, if you're interested in any other videos, please do check them out. And well, thanks a lot.